Right. So my voice is audible to you and my screen is visible to you, right, ma'am?
Yes, yes.
Okay.
Your voice and screen both are visible.
Okay, right. Fine. So thank you very much. This is paper ID 9, and I'm very happy to participate in this international conference. This topic is all about a novel, low cost visual aid system for the completely blind people. So definitely it will be beneficial for the current generation and the future generations to come. And I would like to share this research paper with especially the faculty members, learned scholars, and young researchers in this field. And this is Dr. Christo Ananth for you. You can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving this golden opportunity to share this useful session, to share my knowledge among my fellow national and international participants, students, and young researchers. And thank you, my dear officials and head of the department who understood the need to initiate the fruitful outcome on teaching, learning, and education. And thank you, my dear colleagues and fellow participants who understood to support this session by your valuable presence. And this is what we are going to discuss at a glance. We'll have a short introduction and I'll discuss about the importance of artificial intelligence, some key objectives of our proposed system, the literature survey, proposed system, Raspberry Pi architecture, the significance of Raspberry Pi in our proposed framework, and the block diagram of our proposed visual aid system, single object detection system, and I'll discuss some example about the specifically detecting the multiple objects with various confidence levels from a single frame, and then I'll have a summary, we'll have some references, and of course I have a short video if time permits about our proposed system. So I can very well present this proposed system to have a innovative visual aid framework for the completely blind people, which takes a form of a pair of glasses, just like I wear. And this is a complicated algorithm processing with the Raspberry Pi 3 Model B+. So it's definitely having low end computing power when it compared with the existing or maybe the literature survey. If you can understand from our proposed system, we have the dual detection and distance measurement capabilities using a combination of camera as well as ultrasound sensors, in addition to the GPS based location tracking by using the IoT device. So I can very well assure that using this proposed system, we have better access and navigational ease to the blind people, to the completely blind people. So these are the key objectives of our paper. I can very well assure that it offers information about the moving barriers from a distance to the readership through the use of the real-time reading assistant, and it's scoring better in case of recognizing objects in a live video stream, and we can get the output to the user in full resolution. Like using the proposed system, we can produce like 98% accuracy, and user's location will be tracked by GPS and reported to their guardian through the IoT website. So, with the case of the literature survey, we very well examine the smart glass system. It's able to detect and recognize the roads. Okay.
Okay.
So, with the case of, thank you for the suggestion. So, about the literature survey, we use the smart glass system. So here we
Good
detect and recognize road signs in real time in urban places, maybe like public restrooms or maybe restaurants or maybe bus stations. Still, the system, if you can observe, it's a tiny, lightweight, portable, and easily adaptable. But the thing is that simply reading of the road signs is not considered as a sufficient information to make them feel secure, because you have to assess them and you have to make them comfortable, and it is possible that a sign will not be recognized in the systems database if it is not recorded in the systems database, because the public signs differ from city to city. So that's the reason our proposed system scores over the existing system, because we are not only recording it, but we are offering much more features with the case of having a comfortable environment. Even we have a context aware navigation services which are able to better assess the visually impaired users. But the ability to communicate about the objects as well as the places improves when people connect, or maybe when they are moving from one place to another. The travel decisions are different, so there is increased ability to communicate. Okay, keeping all these minds, with the case of visual cues and distance sensing of physical objects, LOS interactions for interpreting the geographical context information, or maybe you take in the case of social media tweets as event based interactions for evaluating the vibes. We take this important factors into consideration into our proposed system. Even in the case of the existing system, we have uh, ETAs, innovative ETAs, electronic travel aids, which are in the shape of a pair of spectacles, okay, which has still travel difficulties experienced by the members of the visual impaired population. Still, if you take in the case of assistance or support, we have adequate and safe training. uh, with the case of novel multi-sensor fusion-based obstacle avoidance algorithm, it uses depth sensor and ultrasonic sensor to overcome the difficulties, maybe having a high degree of precision. So these are all the disadvantages that are taken into consider when we try to evaluate the proposed system. Still, we are able to see visual augmentation with the AR technique, augmented reality technique, which combines the traversable direction. On the other hand, it's generally beneficial to the visually impaired folks. So several people have tried out this prototype, but the thing is that the spectacles are handy. It's very comfortable, but still it has to have a high degree of precision, and that's the reason our proposed system scores with the case of efficiency as well as accuracy. So in our proposed system, we have a visual aid that's both accurate as well as reliable in order to aid the visually impaired individuals. And if the person wearing the glasses, he can or maybe she can attach the visual aid to provide both indoor as well as outdoor navigation. So moving between places, we are able to get the better connectivity. And talking about the handy based approaches, it's small, lightweight, and completely hands-free technology. And this technology will aid blind individuals because it can distinguish between fixed and moving objects in real time, and it can provide oral feedback. Even with the case of the accurate distance measurements, it can be taken in real time because the sensors we use are very less and cameras are very less even. And we have the simplified design. The cost is also reduced when you compare it to the existing system. Also, when you talk in terms of connectivity, we have a blind person can easily track the GPS location and send messages to family members or guides directing to the IoT website. So we have a good advantage. When you talk about the price and portability, they are most significant. When you take in the case of the Broadcom technology that we use over here, we have inbuilt a single piece of hardware with BCM2837 quad-core 64-bit processor. Space, 1 GB RAM, wireless LAN, we have BLE, we have Bluetooth low energy device, and the board even. Okay. So the board, we have the 100 base Ethernet GPIO, and with 40 pins, we have a full size HDMI connection to connect the Raspberry Pi device to the display of your choice. And if you do not choose the USB port, you can connect a camera directly to the Raspberry Pi. You can have a micro USB power source with a maximum output of 2.5 amps. We can have a on-off switch as well. So we are having such much advantages with the Raspberry Pi architecture that we have explained over here. And the significance, we have the Raspberry Pi, which supports a person in charge of the visual aids, and we have the USB camera, which is used to identify the items in the local surroundings and convey the information to the disabled individual. And we have the detected object, which is displayed on the monitor, which is then carry over for the communication with the GPS modem. So altogether, we can summarize that we have created an object identification and tracking framework, which are able to carry out the Raspberry Pi microcontroller board in real time. So here we have an RCNN based approach, region convolution neural network based approach. With the programming part, we have Python for object detection and the object detection technique. Here we use TensorFlow, Keras software, and then text-to-speech libraries. Everything is an open source. So altogether, it's a low-cost, efficient, accurate device, or maybe the accurate framework we have, which enjoys like 98% efficiency and accuracy. So this is the block diagram of our proposed visual light system. We have the power supply, ultrasonic sensor, USB camera that is being fed to the Raspberry Pi. We have the monitor to get the display out of it, and we have the GPS modem. We have the headphone even to assist this completely blind people. So the camera's data were collected using the ultrasonic rangefinder placed beneath it, and in order to use the ultrasound module, we have 4 pins. We are connected to the Raspberry Pi general purpose input output ports, and then we have the output signal of the ultrasonic sensor, which is referred as an echo signal. We have zero signal for low. Nevertheless, when the sensor is active, it can generate a high, maybe 5 volts signal. So one of the GPIO pins is configured as output, which can signify or maybe signal that the sensor is being activated. So we also have a single 10-second pulse, which is required to turn on the HC ASR04 sensor, and this sensor generally emits the ultrasonic burst at a frequency of around 4 kilohertz, and we have 8 ultrasonic pulses at the frequency of 4 kilohertz. We have a trigger pin as well for triggering the pins to the from the reset to the low, and which can generally signify and broadcast these pulses. And when you detect this particular signal, the sensor's echo parameter is increased by the sensor. And if you talk about the parameters like the operating speed, we have 343 meter per second, which is same as the sound speed at the sea level. So that's a pretty much fast device that we have in this framework. So we have a single object detection system. So cell phone, we can enjoy 97% confidence level, and if you consider like detecting multiple objects with various confidence levels, we can of course enjoy them with the picture net data collection technique. So the network generates a bounding box around an item and tries to determine its kind based on the data that we are providing. So every frame will be having a set of bounding boxes which can be identified using the simple background classes. And as I told you, RCNN feature, we have the downsampling convolution feature, which maps to reduce the unneeded bounding boxes, which is used to prevent this problem from occurring. So I can summarize that it's a novel kind of eyewear for the persons who are completely blind, and this is sophisticated algorithm can be executed on the Raspberry Pi model B+, and IoT AI on ML. We offer huge advantages for navigation, for conjunction with the ultrasonic sensors, with the IoT based location detection for measuring the distance between the objects. So thanks to these greater advancement in the technology, because we are able to enjoy efficiency, comfortability, accuracy, and greater convenience, ease to use. And these are the references. I have gone with several references.